Hello everyone, I am Brandon Ordonez from ECE31 and I am here to present our summative assessment 3 for our power electronics lecture and laboratory. Hello everyone, so let us now proceed with our summative assessment. So first, the problem is a single phase bridge rectifier has an RL load with R is equal to 10 ohms and L is equal to 25 millihertz. So this is the resistance and this is the inductance values. The AC source is Vs is equal to 170 sine 377 T volts. Determine the average and RMS currents in the load and in each diode. So first, we have solved the values, the theoretical values for the average load current, RMS load current, average diode current, and RMS diode current. So the values displayed are as follows. So now we will be getting the measured value or the experimental values for these current values. So we would open our CAD. There, I have already built the circuit. First, our AC source is a sinusoidal voltage source with an amplitude of 170 volts and a frequency of 60 Hertz. Next, we would use 4 diodes with the break as their default values. Next, a resistor with 10 ohms value and an inductor with 25 millihenries value. So after we have built the circuit, we will edit our simulation settings. So for the time domain, transient, our runtime would be 83.35 milliseconds. This is 5 times the cycle or the period of one cycle of our frequency from our source. Start saving data after 0 seconds, then maximum time step of 10 microseconds. So after that is good, click OK and simulate. Okay, so first we would add trace. First we would be using the average load current. So for the load current, we'll be using R1. Next, for the RMS load current, there. And next, for the average diode current. Next, for the RMS diode current. There. So now that the waveforms have appeared, it is we can measure their average values by going at the far end section of the waveform because it is represented as 5 times the cycle. So the values is ideally the same at the first cycle, which is 16.67, at the second cycle, third cycle, and so on until it reaches the 5th cycle. So here, these are the values used. So let us compare. So for the average load current, it is 10.179 amperes. Next, for the RMS current, RMS load current, it is 10.550 amperes. Next, for the average diode current, it is 5.2092 amperes. And for the RMS diode current, it is 7.5590 amperes. There. So now that we have attained the values, let us collect the waveform that we have gathered. Next, we would gather the data that was collected. The color is with respect to the color of the waveform. There. So now that we have collected the waveforms and their respective values, let us now compare. So for the average load current, the computed value is 10.8225 amperes, while the measured value, which is gathered from the PSpice simulation, is 10.179 amperes. Next, for the RMS load current, the computed value is 11.0865 amperes, while the measured value is 10.550 amperes. Next, for the average diode current, the computed value is 5.4116 amperes, and the measured value is 5.2092. Lastly, for the RMS diode current, it is 7.8393 amperes, while the measured value is 7.5590 amperes. Note that the average diode current is equal throughout the 4 diodes used in the simulation. Conclusion. The summative assessment involved the gathering of data from a single-phase bridge rectifier. Initially, the computed parameters were gathered through the mathematical solution presented in the paper. Afterwards, the experimental values were gathered using the simulation software OrCAD and PSpice. After building a circuit, the waveforms were shown with their RMS and average values displayed collectively in the panel. The measured values were observed to be close to their computed counterparts, which therefore leads to the conclusion that the computed values of the parameters needed are correct.